Over 110 years ago, Viking Pump started as a single pump in an Iowa quarry, and now is a global manufacturer with products that are shipped all over the world. We employ the best people to work in our state-of-the-art facilities, and we build our highly engineered products from the ground up. And that's why Viking Pump is the global leader in positive displacement pumping solutions. Cedar Falls, Iowa is home to Viking Pump's world headquarters, and this is where the pump design process begins. Viking Pump is located in the original building the company was founded in over 100 years ago. Over the years, the building has undergone multiple expansions and formerly housed both manufacturing and office staff. As Viking Pump grew, additional space was needed, and manufacturing was moved to the Cedar Falls Industrial Park. Today, the downtown Viking Pump headquarters is home to the executive offices, customer service, accounting, human resources, IT, marketing, engineering, and the product engineering lab. Before the manufacturing process can begin, the creation of a pump begins with the design process. Viking Pump's engineering team creates computer-generated models with exact measurements and design specifications. Viking Pump's full team of designers, mechanical engineers, and material engineers utilize a variety of tools, including 3D CAD software, finite element analysis, and casting analysis to verify design viability and the ability to consistently manufacture. Engineers are then able to rapid prototype using 3D printers in our technology center, which is essential in getting new ideas in the hands of customers to ensure our solutions are meeting both customer and application requirements. Full-scale operational prototypes are also tested in our product engineering lab to validate performance requirements. Once designs have been finalized, manufacturing can begin. The first step in this process starts in our foundry. Located on Viking Road in the Cedar Falls Industrial Park, the 78,000 square foot foundry is used to produce gray and ductile iron, carbon steel, 316 stainless steel, and 770 non-galling stainless steel. In a foundry, parts are cast by pouring molten metal into a hollow mold. To create a mold, patterns are pulled for the various cast parts required. Each pattern is a template for one side of a cast part or multiple parts. Sand will be compressed against the plate, and when the plate is removed, the shape of the part remains and half of a mold is created. Parallel to the mold-making process, the metal is being prepared at the foundry melt deck. A mix of raw ingredients and foundry scrap are mixed in a furnace. Periodically, molten metal is checked for temperature and chemistry. If the chemistry is incorrect, additional components are added in specific weights to achieve the desired properties. When proper temperature and chemistry are achieved, the furnace is poured into a waiting foundry ladle. Impurities are gathered at the top and removed from the crucible, and a sample bar from the heat is poured. The molten metal is now ready to be poured into the various part molds. Timing is critical to ensure that the temperature of the metal is maintained high enough to complete the required number of parts. Once cooled, the mold is broken and the rough casting is cleaned. Excess metal is cut away and recycled, and the rough edges are ground smooth. Some materials like stainless steel require heat treatment. These parts are heated in an oven and cooled in a water bath. Finished castings are moved to the casting shed, which connects the foundry to Viking Pump's machine shop. This is the transition point between the foundry and machining. Viking Pump's largest facility is the machine shop. Since its opening in 1960, this facility has undergone multiple expansions and grown to 320,000 square feet. Today, this facility houses many departments, including machining, tooling, assembly, paint, shipping, quality, procurement, and planning. In the machine shop, parts are machined from castings and bar stock. Dimensions, especially those inside the pump cavity, must be precise to ensure the pumps operate efficiently and are capable of high pressures and self-priming. Quality checks are made throughout the machining process. In the sub-assembly area, individual parts are pressed or pinned together into sub-assemblies. Examples include rotor and shaft assemblies, and idler and bushing assemblies. These and other parts are gathered together for final assembly. In final assembly, the parts and sub-assemblies are put together as a complete pump according to the pump's bill of material. Local manufacturing and distribution also occurs at a handful of locations across the globe. These include IDEX Technologies Suzhou in Suzhou, China, IDEX India in Vadodara, India, Viking Pump Hygienic in Eastbourne, United Kingdom, and IDEX Pump Technologies Ireland in Shannon, Ireland. Prior to shipping, each Viking pump receives a quality test. For most pumps, this involves a run test and hydrostatic pressure test. Pumps requiring certified testing are transferred to the Viking Pump Product Engineering Lab. Here, pumps are tested at customer-specified speed, pressure, and liquid viscosity to ensure performance at the customer's unique application requirements. These tests may be complete unit tests or performed on one of Viking Pump's 9 dynamometers. Once the pump has passed all testing, it can be staged for painting. In painting, most pumps receive a coat of Viking blue paint. For external gear products, this is a UV Cure epoxy paint, and for other products, this is a water-based paint. While many pumps, especially those for replacement, will be shipped individually, others need to be built into a complete unit. Viking Pump units include the base plate and may also include the motor, couplings, guards, reducer, or V-belts. Completed pumps and units are then boxed and shipped to Viking Pump distributors and customers all over the world. Over the course of more than 110 years, that's been over 7 million pumps and counting.